Good morning. I'm Spot On Weather meteorologist Matthew Euler, and on this video we're going to take a look at past winter weather. As we head into November time frame at the present time, it's always good to take a look back at the historical record, and maybe we can figure out a pattern of some sort, or it's just interesting to go back and take a look at that past weather. So let's kick it off here. We're going to start off with looking at past winters. And we're going to look at the meteorological winters, all right? So that's December, January, and February. And we're going to look back from 1895 to the present time. So what I'm showing you here on this graphic is the zero, if you go horizontally across with the zero line, that generally represents a normal temperature range. So basically there's no departures from normal if these little areas, for example, that right there, that little spike, this one as well, if it falls right on the zero line, there's no departures from normal. Now, all the red areas show you warmer than normal conditions. And on the scale here on the left, I have the degrees. Okay, so there's degrees Celsius on the left. And then on the bottom, I have the years from 1895 all the way to 2015. So the blue areas indicate winters in which it was colder than normal. And so the larger the spike, the colder or warmer the temperatures were for that winter here in the U.S. continental lower 48. So if we look back, and this is at the United States as a whole, not just at Southeast Virginia, we look back at the warmest winters, December, January, February timeframes from 1895 to present. They included 1934, where the average temperature was plus 1.78 degrees Celsius. 1954 was plus 1.84 degrees Celsius. 1992 was a very warm winter as well, at plus 1.97 degrees Celsius, almost 2 degrees Celsius above normal. Looking back at the coldest winters out of this whole data set, we see that 1895, the beginning of this time frame, the average winter temperature from December through February was 2.96 degrees below normal. In 1936, it was 2.3 degrees Celsius below normal. And then the winter of 1979, which some folks really remember across the East as a very cold winter, it was down to 3.13 degrees Celsius below normal. So over time, you notice these ups and downs, ups and downs. In the most recent memory, going back to 1985, you'll notice more of a departure above normal by these red hashed areas. So it's been warmer than normal a lot of the winters. So some people say, where have all the winters gone? Where are the winters? Why have the winters changed so much recently? So, and that is open to a big debate on whether it's caused by global warming or whether it's caused by natural climatic variations in the earth. All right, so we're going to look back at a couple of diagrams showing the warmest and coldest years. On each of these charts, by the way, this data is courtesy of the Oregon State Prism Climate Group. So really appreciate that. Want to give them credit. We are using their data and their reanalyzer information here. Starting off with 1976, December, January, February. The oranges and the reds, these are above normal temperatures, by the way. If anything's in blue on these charts, it indicates below normal temperatures. The temperature scales are at the bottom of each of these graphics, or each of these maps. All right, so in 1976, December, January, February, was a little bit cooler across New England and also over Florida. But outside of that, it was a pretty warm winter, as indicated by the orange and the brown colors across the U.S. as a whole. 1992 was even warmer, especially across the upper plain states, the northern plains, eastern Montana, North and South Dakota, and Nebraska specifically. That's where the warmest winter weather was in 1992. Again, there was a little bit of cooler areas across Maine and then also down across the desert Southwest, but it was a very toasty winter overall. Looking back at other very warm winters, 1999, just a little bit of cooling along the western coast of the U.S. Other than that, it was very warm. Again, the heat was concentrated over the northern plain states, Nebraska, South Dakota, North Dakota, even into Minnesota and to Wisconsin. And even in this case, in 1999, even all the way up into Maine, it was well above normal for temperatures. In 2000, we had another warm area up in the northern plains, a very warm winter overall, with the exception of some cooler temperatures down over Florida and Georgia and South Carolina at that time. Additional warm winters, 2012, more recent memories now, 2012 and 2016. You can see where the warmth really concentrated itself, especially across the upper Midwest into New England. And again in 2016, a very similar pattern up on the upper Midwest, the U.S.-Canadian border across the Minnesota, Wisconsin, Michigan, and into New England. And then 1998 concludes our warmest winters as far as our data goes back, looking at the PRISM Climatic Group. Really concentrated warmth above basically over the northern United States as a whole. So very warm winter in 1998 as well. Just a few cool spots down in the desert Southwest and into California. But again, a very mild winter overall. Now, on the other hand, let's take a look at some of the coldest winters. Now, these were some very brutally cold winters. The late 1970s were very cold across the eastern United States. A winter which featured temperatures on the range of 3 to 5 degrees Celsius below normal. If you look at the darker purples and the blue shades, this is a very anomalously cold pattern. Across the west, it was much milder. But look at the east in this case. 1977, 1978, it was a little bit further west as compared to 77. But there's a major amount of cold air, especially east of the Rocky Mountains in the winter of 1978. And then in 1979, this string of cold winters continued. So 77, 78, and 79, 3 consecutive winters were well below normal. You'll notice the change from 77, 78, and now 79. Look at how much further back. Almost the whole U.S. is in this purple or blue shading, which indicates below normal temperatures. By 1982, things shifted a little bit further to the east. It warmed up. The winter was a little bit milder across the desert Southwest, the western U.S. as a whole, and the heart of the cold concentrated itself from Canada down into the Ohio Valley and the Midwestern states. It was also below normal here for eastern Virginia at that time. Looking back now at 2010, a little bit more recent time frames, much colder temperatures, especially concentrated across the southern U.S., very mild across the Pacific Northwest and New England in the winter of 2010. And then in winter of 2011, again, very cold from the Canadian prairies all the way down to Florida, actually. So the cold penetrated farther south in 2011 in that winter. Looking at 2014, the heart of the coldest air concentrated itself over Minnesota, Wisconsin, Iowa, Illinois, Indiana. Was mild out to the west. And then 2015, it was much below normal again across the east and very mild across the west. This is the year we had the warm blob. This is where we had that huge upper level ridge parked over the western U.S. and we had extreme cold across the east. All right, so on this chart, moving on, I wanted to show each of these little blue spikes is in the negative territory. Each of these red spikes is in the positive territory. But this is a running average of the Pacific North American pattern over on the left, the North Atlantic Oscillation in the middle, and then the Arctic Oscillation on the right. And what I want to just hint at, so the values here on the left indicate positive. It ranges from +3 to -3. I just want to indicate how the teleconnections, which I did on a previous video, also go through a up and down pattern, just like the overall North American temperature pattern. And so with these spikes, these ups and downs, the red indicate positive phases of the teleconnections in each of these categories, and the blue indicates negative phases. For more information about teleconnections, please see the previous video we put out on teleconnections and winter weather. It's a really good video. All right, and I did want to also mention in this video about the fact that I mentioned this in the teleconnection, or the winter forecast actually, that you can sometimes get anomalously warm sea surface temperatures over different parts of the world's oceans. And where these anomalously warm or cold areas, sea surface temperature areas, set up is critical as far as establishing the long wave pattern or the jet stream pattern, how things are going to set up. The jet stream is an upper level river of air at about 30,000 feet that steers storm systems. It directs different air, basically air masses are warmer in upper level ridges and they're much colder in upper level long wave troughs. And so what happens is with anomalously warmer sea surface temperatures, you get a huge ridge or upper level high pressure that sets up over these anomalously warm sea surface areas. If it's a colder than normal, the blue, if it's a colder than normal sea surface temperature area, you tend to have upper level troughs that form in those areas. So this is a comparison. This is going back now. We're looking back a few winters ago, 2014, to where we had this huge, anomalously, we call it a warm blob over the North Pacific Ocean. And what happened was there was a huge ridge of high pressure that set up right over the top of this into the western U.S. and resulted in a very dry winter for California and the West Coast in general. What happens is with these upper level ridges, they tend to redirect storms over the top. Storms cannot go through strong upper level ridges. They have to go up and over the top of them, and they have to spill down on the east side of the ridges. And so what it sets up is a drought type pattern and also very mild weather conditions. So we have a huge ridge over the eastern Pacific into the western U.S. We generally have a trough downstream or to the east of that upper level ridge. This is showing you the actual sea surface temperature anomalies at the time. We're looking at 2 degrees, 1.5 to 2 degrees Celsius warmth above normal for sea surface temperatures in conjunction with that winter. So bottom line here, I want to end this video briefly by just mentioning that no two winters are exactly alike, okay? Just like people are different, no two personalities are exactly alike, no two winters are exactly alike as well. The teleconnections, there's a lot of research going on into that for seasonal forecasting, but you can have a warm winter one year, like this is 1976, look how mild that winter was. And then you go a year later in the winter, you're extremely cold in the east. And then you have 3 straight winters where it's exceptionally cold. So there's really no rhyme or reason or specific patterns that have been identified as of yet as far as winter weather, seasonal forecasting. There's ups and downs with temperatures, as indicated by our temperatures data going back to 1895. And there's also lots of ups and downs as demonstrated by this graph. I thought it would be fun to take a look at the past winter weather since 1895 over the United States, just to kind of get you a feel for the warmest and coldest winters. All right, that wraps things up for Spot On Weather. I hope everybody has a wonderful Tuesday. Take care out there. Be safe. Remember, if we're not spot on, we're not doing it right. Have a great day, everybody.